Ever wondered how to compare two numbers that look incredibly complex, like 2 to the power of 120 versus 3 to the power of 90? At first glance, it might seem like the one with the bigger exponent is always the larger number. But today we're diving deep into exponent comparison to uncover a surprising truth. By the end of this, you'll not only know which number is truly larger, but you'll understand a powerful mathematical trick to compare numbers with large exponents, even when they seem impossible to calculate directly. Let's visualize these numbers. Imagine a mountain built of blocks. One mountain has blocks of 2, stacked 120 high. The other has blocks of 3, stacked 90 high. Which mountain is taller? The key insight here is to use a clever mathematical tool, taking the 30th root of both numbers. Why the 30th root? Because it perfectly matches the greatest common divisor of our exponents, 120 and 90, which is 30. So we take the 30th root of 2 to the 120, which simplifies to 2 to the power of 120 divided by 30, or 2 to the 4, giving us 16. And for 3 to the 90, the 30th root becomes 3 to the power of 90 divided by 30, or 3 to the 3, which is 27. Now, comparing 16 and 27 is much simpler. Clearly, 16 is less than 27. Think of it like this. If you have two numbers and you take the same root of both, the order of their size doesn't change. Since the 30th power is a monotonically increasing function, if the 30th root of a is less than the 30th root of b, then a must be less than b. Therefore, 2 to the 120 is actually smaller than 3 to the 90. This powerful technique allows us to compare numbers with large exponents by simplifying them into more manageable forms. It's a fundamental concept in mathematics with wide-ranging applications.